UFOGen. You forward once large-scale text-to-image generation via diffusion GANs. Text-to-image diffusion models have demonstrated remarkable capabilities in transforming textual prompts into coherent images, yet the computational cost of their inference remains a persistent challenge. To address this issue, we present UFOGen, a novel generative model designed for ultra-fast, one-step text-to-image synthesis. In contrast to conventional approaches that focus on improving samplers or employing distillation techniques for diffusion models, UFOGen adopts a hybrid methodology, integrating diffusion models with a GAN objective. Leveraging a newly introduced diffusion GAN objective and initialization with pre-trained diffusion models, UFOGen excels in efficiently generating high-quality images conditioned on textual descriptions in a single step. Beyond traditional text-to-image generation, UFOGen showcases versatility in applications. Notably, UFOGen stands among the pioneering models enabling one-step text-to-image generation and diverse downstream tasks, presenting a significant advancement in the landscape of efficient generative models. Work done as a student researcher of Google indicates equal contribution. The chosen one: consistent characters in text-to-image diffusion models. Recent advances in text-to-image generation models have unlocked vast potential for visual creativity. However, these models struggle with generation of consistent characters, a crucial aspect for numerous real-world applications such as story visualization, game development, asset design, advertising, and more. Current methods typically rely on multiple pre-existing images of the target character or involve labor-intensive manual processes. In this work, we propose a fully automated solution for consistent character generation, with the sole input being a text prompt. We introduce an iterative procedure that, at each stage, identifies a coherent set of images sharing a similar identity and extracts a more consistent identity from this set. Our quantitative analysis demonstrates that our method strikes a better balance between prompt alignment and identity consistency compared to the baseline methods, and these findings are reinforced by a user study. To conclude, we showcase several practical applications of our approach. Project page is available at project's website. Contrastive chain of thought prompting. Despite the success of chain of thought in enhancing language model reasoning, the underlying process remains less well understood. Although logically sound reasoning appears inherently crucial for chain of thought, prior studies surprisingly reveal minimal impact when using invalid demonstrations instead. Furthermore, the conventional chain of thought does not inform language models on what mistakes to avoid, which potentially leads to more errors. Hence, inspired by how humans can learn from both positive and negative examples, we propose contrastive chain of thought to enhance language model reasoning. Compared to the conventional chain of thought, our approach provides both valid and invalid reasoning demonstrations to guide the model to reason step by step while reducing reasoning mistakes. To improve generalization, we introduce an automatic method to construct contrastive demonstrations. Our experiments on reasoning benchmarks demonstrate that contrastive chain of thought can serve as a general enhancement of chain of thought prompting. Adaptive shells for efficient neural radiance field rendering. Neural radiance fields achieve unprecedented quality for novel view synthesis, but their volumetric formulation remains expensive, requiring a huge number of samples to render high-resolution images. Volumetric encodings are essential to represent fuzzy geometry, such as foliage and hair, and they are well suited for stochastic optimization. Yet many scenes ultimately consist largely of solid surfaces, which can be accurately rendered by a single sample per pixel. Based on this insight, we propose a neural radiance formulation that smoothly transitions between volumetric and surface-based rendering, greatly accelerating rendering speed and even improving visual fidelity. Our method constructs an explicit mesh envelope which spatially bounds a neural volumetric representation. In solid regions, the envelope nearly converges to a surface and can often be rendered with a single sample. To this end, we generalize the new formulation with a learned spatially varying kernel size which encodes the spread of the density. fitting a wide kernel to volume-like regions and a tight kernel to surface-like regions. We then extract an explicit mesh of a narrow band around the surface, with width determined by the kernel size, and fine-tune the radiance field within this band. At inference time, we cast rays against the mesh and evaluate the radiance field only within the enclosed region, greatly reducing the number of samples required. Experiments show that our approach enables efficient rendering at very high fidelity. We also demonstrate that the extracted envelope enables downstream applications such as animation and simulation. Open sourcing highly capable foundation models, an evaluation of risks, benefits, and alternative methods for pursuing open source objectives. Recent decisions by leading AI labs to either open source their models or to restrict access to their models has sparked debate about whether and how increasingly capable AI models should be shared. Open sourcing in AI typically refers to making model architecture and weights freely and publicly accessible for anyone to modify, study, build on, and use. This offers advantages such as enabling external oversight, accelerating progress, and decentralizing control over AI development and use. However, it also presents a growing potential for misuse and unintended consequences. This paper offers an examination of the risks and benefits of open sourcing highly capable foundation models. While open sourcing has historically provided substantial net benefits for most software and AI development processes, we argue that for some highly capable foundation models likely to be developed in the near future, open sourcing may pose sufficiently extreme risks to outweigh the benefits. In such a case, highly capable foundation models should not be open sourced, at least not initially. Alternative strategies, including non-open source model sharing options, are explored. The paper concludes with recommendations for developers, standard-setting bodies, and governments for establishing safe and responsible model sharing practices, and preserving open-source benefits where safe. The ML Bench, large language models, leverage open-source libraries for machine learning tasks. Large language models have shown promising performance in code generation benchmarks. However, a considerable divide exists between these benchmark achievements and their practical applicability, primarily attributed to real-world programming's reliance on pre-existing libraries. Instead of evaluating LLMs to code from scratch, this work aims to propose a new evaluation setup, where LLMs use open-source libraries to finish machine learning tasks. Therefore, we propose ML Bench, an expansive benchmark developed to assess the effectiveness of LLMs in leveraging existing functions in open-source libraries. Consisting of 10,044 samples spanning 130 tasks over 14 notable machine learning GitHub repositories. In this setting, given a specific machine learning task instruction and the accompanying readme in a codebase, an LLM is tasked to generate code to accomplish the task. This necessitates the comprehension of long and language code interleaved documents, as well as the understanding of complex cross-file code structures, introducing new challenges. Notably, while GPT-4 exhibits remarkable improvement over other LLMs, it manages to accomplish only 39.73% of the tasks, leaving a huge space for improvement. We address these challenges by proposing ML Agent, designed to effectively navigate the codebase, locate documentation, retrieve code, and generate executable code. Empirical results demonstrate that ML Agent, built upon GPT-4, results in further improvements. Code, data, and models are available at the project's website. JaxMARL, multi-agent RL environments in JAX. Benchmarks play an important role in the development of machine learning algorithms. For example, research in reinforcement learning, RL, has been heavily influenced by available environments and benchmarks. However, RL environments are traditionally run on the CPU, limiting their scalability with typical academic compute. Recent advancements in JAX have enabled the wider use of hardware acceleration to overcome these computational hurdles, enabling massively parallel RL training pipelines and environments. This is particularly useful for multi-agent reinforcement learning, MARL, research. First of all, multiple agents must be considered at each environment step, adding computational burden. And secondly, the sample complexity is increased due to non-stationarity, decentralized partial observability, or other MARL challenges. In this paper, we present JaxMARL, the first open-source codebase that combines ease of use with GPU-enabled efficiency and supports a large number of commonly used MARL environments as well as popular baseline algorithms. When considering wall clock time, our experiments show that per run our JAX-based training pipeline is up to 12500 times faster than existing approaches. This enables efficient and thorough evaluations, with the potential to alleviate the evaluation crisis of the field. We also introduce and benchmark SMAX, a vectorized, simplified version of the popular StarCraft multi-agent challenge, which removes the need to run the StarCraft 2 game engine. This not only enables GPU acceleration, but also provides a more flexible MARL environment, unlocking the potential for self-play, meta-learning, and other future applications in MARL. We provide code at the project's website. Tied-Lora, enhancing parameter efficiency of LoRa with weight tying. We propose Tied-Lora, a simple paradigm that utilizes weight tying and selective training to further increase parameter efficiency of the low-rank adaptation, LoRa, method. Our investigations include all feasible combinations of parameter training and freezing in conjunction with weight tying to identify the optimal balance between performance and the number of trainable parameters. Through experiments covering a variety of tasks and 2 base language models, we provide analysis revealing trade-offs between efficiency and performance. Our experiments uncovered a particular Tied-Lora configuration that stands out by demonstrating comparable performance across several tasks, while employing only 13% of parameters utilized by the standard LoRa method.